Have you ever wondered how circuits work? From smartphones to a simple LED, all devices are filled with tiny components, and the most common is this. Well, let's find out.
A resistor is an electronic component that resists or limits the flow of electric current. Think about water flowing through a pipe. If the pipe is wide, water can flow easily. But if we make the pipe narrower, the water flow becomes more difficult. A resistor does something similar to electricity. It makes it harder for electric current to flow through a circuit. Now you might ask, why would we want to make electricity harder to flow? Because sometimes too much current can damage an electronic component. For example, imagine connecting an LED directly to a power source. Too much current could flow through the LED. The LED may get damaged. So we add a resistor. The resistor limits the current and helps protect the LED. You can think of a resistor as a traffic controller for electricity. It does not completely stop the traffic. It simply controls how much electricity can flow. That is why it is called a resistor. The ability of a component to resist electric current is called resistance. Resistance is represented by the letter R, and its unit is called the ohm, represented by this symbol, omega. For example, a resistor could have a resistance of 100 ohms, 1000 ohms, or 10,000 ohms. We commonly write 1000 ohms as 1 kilo ohm, or 1 kilo ohm, and 1 million ohms as 1 megaohm. Now let's learn one of the most important equations in basic electronics, Ohm's law. It tells us the relationship between voltage, current and resistance. The formula is V equals I multiplied by R, or V is equal to I times R. Here, V means voltage, I means current, and R means resistance. We can also rearrange the formula. Resistance equals voltage divided by current, and current equals voltage divided by resistance. This simple equation is used again and again when designing and analyzing electronic circuits. But what is actually happening inside a resistor? To understand this, we need to look at electricity at the microscopic level. Electric current is caused by the movement of electric charges. Inside a conducting material, electrons move through the material. When they move, they interact with the atoms and other parts of the material. These interactions make it harder for the electrons to move in an organized direction. This opposition to the movement of electric charge is what we observe as electrical resistance. And because of this resistance, some electrical energy is converted into heat. Every resistor has something called a power rating. Power tells us how much electrical energy the resistor can safely convert into heat. Power is measured in watts. For example, you may see resistors rated at 1/4 watt, half a watt, 1 watt, 5 watts, or even much higher. If a circuit makes a resistor dissipate more power than it can safely handle, the resistor can become extremely hot and may fail. So engineers always consider both the resistance value and the power rating. That is why a resistor can become warm when current flows through it. Here is another important concept. The resistance of a material depends on several factors. One of them is the material itself. Different materials have different electrical properties. Resistance also depends on the length of the resistive path. Generally, a longer path gives higher resistance, and a thicker path generally gives lower resistance. The relationship can be written as R equals ρ multiplied by L divided by A. Here, ρ represents the material's resistivity, L represents length, and A represents cross-sectional area. This principle is very important when resistive elements are designed. A resistor's printed value is not always its exact real-world value. For example, imagine a resistor labeled 1 kilo ohm plus or minus 5%. This means the actual resistance can be slightly higher or lower than 1 kilo ohm. This allowed variation is called tolerance. Common tolerances include 5%, 2%, 1%, and even much smaller values for precision resistors. A smaller tolerance means the resistor's actual value is closer to its specified value. There's another important specification called the temperature coefficient of resistance, or TCR. A resistor's resistance can change slightly when its temperature changes. TCR tells us how much the resistance changes with temperature. This becomes very important in precision electronic circuits. For simple circuits, a small change may not matter much. But in measurement equipment and precision electronics, even a small change can affect the accuracy of the circuit. So, now we know that a resistor is much more than just a small component on a circuit board. It controls the flow of current, protects sensitive components, converts electrical energy into heat, and plays a very important role in electronic circuit design. We also learned about resistance, Ohm's law, power rating, resistivity, tolerance, and temperature coefficient of resistance. These may seem like simple concepts, but they form the foundation of electronics and will help us understand much more advanced circuits in the future. In the upcoming videos, we'll explore more important electronic components and understand how they actually work. So, if you found this video helpful, don't forget to like this video, share it with someone who is learning electronics, and subscribe to Smart Techies for more simple and easy to understand technology videos. Thanks for watching, and I'll see you in the next video. Until then, keep learning, keep exploring, and keep experimenting.